root finding is an important problem in mathematics and one that we're going to use often in this course. So it's important to have good numerical methods for root finding. Root finding means that we want to solve the equation f of x equals 0 for a root, which we'll call x equals r. The first numerical method I'll discuss in this video is actually the slowest converging one, but it has the advantage of always finding the root. That's called the bisection method. So let's graph what it means to find a root. So if this is our x and y, and we're looking at a function y equals f of x, so say the function looks like this. So the place where y is 0 is the root. So this point here is the value of r. And we will want to determine the value of r using some iteration method. Bisection is the method where you start with two values. Let's say here and here. We say that these values bracket the root. One value is smaller than r. The other value is larger than r. You can test whether these two values bracket the root by calculating f at those values. F has to change sign between these two values. Let's call the first one x0 and the second one x1. So we start with x0 and x1. Bisection method says that the next value then is going to be the midpoint of x0 and x1, the average value of x0 and x1. So that will be, say, here. And this value here we'll call x2. Okay? Then we proceed by choosing x2 and one of x0 and x1, depending on which one brackets the root. That means the root is between them. Here we would choose x2 and x0 because that brackets the root. And then we find the average of those two values, and that will get us, say, here. And this one here will be the value of x3. And then we iterate. So this is the bisection method. The width of the interval of the bracket, the interval that brackets the root, will decrease by a factor of 2 with each iteration of the bisection method until you get convergence. So we can write the formula for the bisection method. So starting, let's write just for x2. So x2 is equal to x0 plus x1 divided by 2, right? And if you wanted to write that as a proper iteration equation, this would be you take the previous value, x1, and then we have x1 over 2. So you can subtract x1 over 2 and add x0 over 2. So x1 minus x0 over 2. Okay? So in the iteration, you start with x0 and x1, and then you change x1 by this amount to get x2, and then you iterate. Okay? But you're not always going in sequence. You're not always going x0, x1, x2, x3, because you might you have to choose the previous two values of x that still keep the root bracketed. Okay? Let's try a quick example. So let's compute the square root of 2. I'll use this example for all of our methods. So compute square root of 2 using bisection method. As a reference, the value is 1.11421. Okay? So how does this proceed? We need two initial values that bracket the root. So let's say I can take x0 equal to 1 and x1 equal to 2. So x0 and x1 bracket the root. Our next value is x2. In a code, you would use this second equation because you would want to test for the correction term to be smaller than some value. But here in the hand computation, it's easier for me to use the first one. So x2 is x0 plus x1 divided by 2. So it would be, say, x1 plus x0 divided by 2 would be 3/2, which is 1.5. Okay? Now we have 1, 2, and 1.5. So we need to bracket the root. So we would choose, we would use x0 and x2 to bracket the root to compute x3. So x3 would be the average value of 1 and 1.5, or 1 and 3/2. So 1 plus 3/2 divided by 2, and this would be 5/4, which is 1.25. Okay? To continue for x4, first we have to decide what brackets the root. So you can test the value of f of x3 and f of x2 and f of x1, decide which ones bracket the root. I know the answer because square root of 2 is 1.4. So here x2 and x3 bracket the root. So I can use x4 then as the average of x2 and x3. So it's 3/2 plus 5/4 divided by 2. Then is 6 plus 5 over 8. So that would be 11 divided by 8. And 11 divided by 8 is 1.375. Okay? And then you can keep going in the bisection method. So we had the sequence then 1, 2, 1.5, 1.25, 1.375. We're trying to converge to square root of 2, which is 1.414. And you see we're not getting there very fast. So this is a slowly converging method. Okay? That's the problem of the bisection method. So if you're interested in speed, and some of the problems we'll solve will require speed, you would not want to use the bisection method. But it's a nice method to have in your toolbox because it always converges, right? Always converges. Okay, so let me summarize. In the bisection method, you need 2 starting values. The values have to bracket the root. So f of one of the values has to be positive, and f of the other value has to be negative. So you can always test the sign of f to find the 2 values that bracket the root. Starting with x0 and x1, x2 is just the average of those values, the midpoint. And then you either choose x0 and x2 to continue, or you choose x1 and x2. You keep the root bracketed. And then you go ahead and you iterate. In the next video, we'll look at Newton's method, which is the fastest converging method. I'm Jeff Chasnoff. Thanks for watching, and I'll see you in the next video.